Okay, welcome back to the channel Computing underscore teacher. And this is the third video in the series of topic for computational thinking, pseudocodes, and programming, problem solving. Okay, so now in this particular video, we are going to talk about operators. Okay, operators. So what are operators? Now, before understanding the concepts of operators in the field of computing, let us do a bit of quick revision in mathematics. How do we do it? Like say, for example, in algebra, right? We write A is equal to 5, B is equal to say 6, all right, 6. And then we say C is equal to A plus B. So technically, what are you doing? You are replacing the value of A with 5, adding it to the value of B with 6, and then you say that the value of C is equal to 11. Okay, so what did you do? You performed an operation over here. Operation. All right. Now, what is this operation that you did? You performed an operation of addition. All right. Addition of what? Two variables, A and B. All right. So these two quantities A and B, those that are variables over here, are called as operands. Okay, operands. So operands are the quantities on which a particular operator performs an action. Okay, so what is the operator that has been performing an operation over here is the addition. So this plus sign is called as the operator. Okay, so A and B are the operands and the plus is the operator. Okay, so here in this particular topic, we are going to understand what are the different operators that we use in the field of programming and while writing our pseudocodes. Okay, so the first operator that we are going to look at is the assignment operator. Okay, assignment. So the assignment operator is the equal to sign. Okay, so as the name suggests, the equal to sign is going to assign something to a quantity. Okay, so say for example, you have taken the variable as A and we are writing A is equal to 5. So what's happening over here is that the quantity 5, which is a constant, is being assigned to the variable A because of this operator equal to, which is called as the assignment operator. Okay, so something that you have to be mindful of is that I cannot write 5 is equal to A. In algebra, it would be okay, but here in computing, it cannot. Okay, so according to computing, A is equal to 5 is a non-acceptable statement. Okay, so what happens is that the right hand side variable value, constant value, will always be shifted to the left hand side. So the variable A will get the value of 5 upon the application of this operator, equal to, called as the assignment operator. Okay, so be careful over here. Don't write 5 is equal to A. All right, okay. So after the assignment operator, we have another set of operators which is called as the arithmetic operators. Okay, so arithmetic operators. Now these arithmetic operators are also some referred to as the mathematical operators. Mathematical operators, arithmetic or the mathematical operators. As the name suggests, we have first operator plus for addition. So this is addition. Okay, then this minus is for subtraction. Then you have this asterisk. Now this is for multiplication. All right, then you have the operator for, now this is div, div, so we write it as div, div, and in pseudocodes it's prominent. Okay, so div, so this one is for division. Okay, for division. And then we have an operator which is called as the mod. This is called as the modulo operator. Okay, so addition, no different from mathematics. Subtraction, nothing different from mathematics. Multiplication, nothing different from mathematics. But this division and modulo are slightly different in its working. Okay, so now let us see how this division, div, and the mod works. So let's take an example. Okay, say for example, I have the variable x which is equal to 17. I have the variable y which is equal to 2. And if I write x div y, okay, so what will happen? How is the pseudocode going to function, or how the logic is going to function over here. Okay, x div y. So we are doing 17 div 2. Okay, so we just replace the values. Now let's perform the division, mathematical division. We are taking 17 2. So basically what will I get? 8, 16 and 1, which is the remainder. So this is the remainder that I get. Okay, now what happens is that we can also write this. I've left the remainder over here, but if we write, then 17 divided by 2 will be 8.5. Okay, 8.5 in fraction. Okay, so when we do div, what happens is that it is going to return only the integer part of the division. Sorry, the quotient. Okay, it's only going to return the integer part of the quotient. So the result that I'm going to get is equal to 8. The fractional part, 0.5. Okay, this is truncated. Truncated means it is not considered, it is removed from the result. Okay, so if we do 17 div 2, I'll get the integer part. Okay, now let us look at the same thing, but we are doing x mod y. So in this case, what is happening? This will be is equal to 17 mod 2. Okay, so the same division will be done. Okay, same division will be done. So 17 to 8 to 16, and the remainder is 1. But this time what we are going to get is the remainder as the result. Remainder. So the result is the remainder over here. All right, so that means I will get my output as 1, which is the remainder. So this is what I am going to get back. Okay, this is what I am going to get back. All right, so this is the difference between the div and the mod. All right, so in programming, the mod is the percentage sign as the mathematical operator. So in pseudocodes, you can write the percentage sign also in place of writing mod. Okay, both will be acceptable. All right, so this is the difference between div and mod, and this is how it is used. All right, I hope the arithmetic or the mathematical operators are clear to you. Now, after the arithmetic or the mathematical operators, we have another set of operators, which is called as the relational operators. So the third set of operators is called as the relational operators. T-I-O-N-A-L, relational operators. Okay. Now the relational operators, we have again equal to. Okay, equal to. Now equal to. So in the previous assignment operator, what did we see? We saw that it is assigning. The same equal to sign is assigning. Okay, but here we are using the same equal to sign as a relational operator. So the purpose changes over here. So how it is being used here, that matters. So when I am using the same equal to sign to make a comparison, I am using it as a relational operator, whereas when I'm using this equal to sign to give a value to the variable, I'm using it as an assignment operator. So be careful where it is being used and how it is being used. All right, so what matters is the function. All right, so say for example, I want to check if the value of a is equal to 7 or not. Okay, so over here what is happening is that a comparison is being done. A comparison is being done, that whether the value of a is equal to 7 or not. Okay, whereas if I write a is equal to 7, here the value of 7 is being assigned. So here is the difference. If I use it with an if, I am making a comparison. I am checking a relationship between the right hand side value and the left hand side value. Whereas over here, I am assigning the value of 7 to the variable a. So this is an assignment operator over here. All right. Remember, in actual programming, the relational operator is double equal to written like this. All right. So this is something that is used in actual programming, but in pseudocodes, according to IBDP curriculum, we use the single equal to. So be careful of whether the if construct is being used or not. Okay, that will be the difference. However, in pseudocode, if you write equal to for the relational operator, it's most likely that it will be accepted. However, it's always going to be saved safe to use the single equal to because it's as per the pseudocode notation sheet. Okay, all right. So this was about the equal to. After that, you have this greater than. Okay, so we are checking whether a quantity A is greater than quantity B or not. Okay, so this will return either true or it will return false. Okay, then you have this greater than or greater than equal to again. So since here the relationship is being checked, so obviously it's not going to return a number. All right, it is always going to return true or false. This is less than. Okay, this one is less than or equal to, less than equal to, q u equal to. Okay, now mathematically how we write it, we write this way. All right, or we write it like this. But in our computing, okay, so this is written maths. So be careful. All right, but in computing we write the greater than sign and the equal followed by the equal to sign, or the lesser than sign followed by the equal to sign. Okay, then you have another operator here in this relational operator, and that is called as the not equal to. So the not equal to is equal to, and you just simply strike it out. Okay, so this is not equal to. So this is the same way how you write in mathematics, not equal to. All right, programming. All right, so even if you write this in pseudocode, it's going to be accepted. Okay, so need not worry about it. So say for example, two quantities, I want to check whether A is not equal to B. I will write it down like this, or I can write it down like this: A not equal to B. Both are accepted. Okay, and of course all of these relational operators are going to return either true or false because they are checking. Okay, be mindful, they are checking for the relationship between the two operands. Okay, so yeah, I hope I have covered the all the logic relational operators greater than, lesser than, equal to, not equal to. Okay, all right. Now let's move on to the next set of operators. The next set of operators is called as the logical operator. Okay, so this is my fourth set of operators. This is called as the logical operators. Okay, logical operators. Now, what are these logical operators? So, logical operators are performing decision making over here. They're checking for logic. Okay, decision. All right. So, the different logical operators you have, the first one is the AND operator. Okay, then you have the OR operator, and then you have the NOT operator. These are all the three logical operators that you have: AND, OR, and NOT. Okay, and let us understand AND now. If I say that please give me the textbook and the notebook, that means you are going to provide to me both the textbook as well as the notebook. All right, because that's the condition. And all right, so here we require two operands. Otherwise and will not be possible. Okay, next is OR. Give me the textbook or the notebook. So you can give me either the textbook or the notebook. That means again I require two operands over here. All right, two operands. Otherwise again it is going to be meaningless, right? So in AND both, and in OR either. All right, and in NOT what it does is it inverts. So for inverting we require only one operand. Okay, not true, that means it is going to give out a false. Not false, that means it's going to give out a true. Okay, so if you look at it for the and the or, minimum two operands are required. Therefore this is called as a binary operator. Okay, because minimum two operands are required in both the cases. However, this is called as the ernary operator. Meaning only one operand will be required. It does not require two operands. All right, until now I hope everything is clear. Now let us look at the different and or and not operators, how they function. So A and D and. Now, as we said, the two operands are required. So let us take two operands, say for example, x and the second operand y, and let us see what output this provides. Okay. Now, AND operator. So say for example, the first condition is true, which is x is true. The second condition y is true. The output obviously will be true. The textbook and the notebook. If you provide me both, obviously you're satisfying both the conditions and the output will be true. Now say for example, textbook is true and the notebook is false. X is true and the Y is false. That means you have the textbook, but you don't have the notebook. So in that case, the condition is getting out to be false. You are not in a position to provide both of them at the same time. Okay. Now let us say that you don't have the textbook, but you have the notebook. All right. So again, what will happen is that it will return false. Why? Because you don't have both of them. This time you don't have the textbook with you. However, you have the notebook. All right. Now, what is it? Both are not there with you. The ultimately the final result will obviously be false. Okay, so let's see how we can work it out. Okay, let's see, say for example, the value of a is equal to 5 and the value of b is also equal to 5. Okay, let's check a condition over here with the AND. So let's check, is a greater than equal to b? Okay, and let's say c is equal to 6, and let's say we saying c greater than b. Okay, so I have used three operands over here. Minimum two are required. I have used three operands. We'll also see that concept. So is the value of a greater than or equal to b? A is 5, b is 5. So this condition is true. All right, then we have this AND. Then c greater than b. C is 6, b is 5. So this condition is also true. So finally, what is happening is that the resultant is going to be true. Okay, so that means if I consider this relational check as my operand x, and if I consider this relational operation as my condition y, I have x as true and y as true, and ultimately my output is going to be true. Okay, let's check another condition over here. Let's see that the value, we're just making a change, right? So let's say a is greater than b, and we are checking c greater than b. Okay, we are doing a greater than b and c greater than b. We are checking this a and d. I do not know for what reason the red color was kind of little too faded out. All right, so let's check this. Now what do we get? Condition a greater than b. A is 5, b is 5, a is 5, b is 5. So this condition is false. All right, and c greater than b, this condition is true. So false and true. What will I get? You guessed it right. Wonderful. It is going to be a false. So this is how the AND logical operator works. Okay, similarly, or, so if I have two operands x, y, and I want to check my output. All right, so I have x is true, y is true, I'll get it true. If I have either my notebook and either I have my textbook, okay, or maybe I do not have my textbook, okay, I have my notebook but I don't have my textbook, then obviously my output is true because I can provide either one of them. The teacher has asked me, give me either your textbook or your notebook, not a problem. Now let us see, I have my notebook, I don't have my notebook, however I have my textbook. All right, so again the satisfied condition is satisfied because I can provide either one of them. All right, now the problem is that I don't have either of them, right? In this case the teacher is going to get angry. Why don't you have your notebook as well as your textbook? Okay, so this is the condition for OR. Similarly, you can work out your own example and see. If you don't get it, try watching the video once again. Okay, so try an example on your own, or maybe you can comment it. What example did you try? Okay, and the last and the final one is the NOT operator in the logical operator. So not requires only one operand, so x, and the output will be not of x. So if I do an x true, my output is going to be false, and if my input x is false, then my output is going to be true. Okay, so mostly what happens is that this not operation is used with the while condition or for any condition check. Say for example, while not, this is how we write, not true. That means this is going to return false. This condition will be false. All right. So this is how it is used, and also if you notice, then it is inverting it. So if the inverting it, so if it is true, I get the output as false. If it is false, the output is true. Okay. So this was all about the operators. You can try a few examples, comment in the comment box, and let me know if you need any further help on this. Okay. So do like, share, and subscribe, and keep me going. Okay. Happy learning.